This is M. Manjaya, lecturer in mathematics, Government Degree College, Sciences, Nagar Karnool District, Telangana State. Today we discuss cosets and Lagrange's theorem. Definition of the coset. If H is a subgroup of G, then the set AH equal to A small h, where small h belongs to capital H, is called the left coset of H in G generated by small a, and the set HA equal to small h into A, where H belongs to capital H, is called the right coset of H in generated by A. Simply these two are called cosets. Small a is the left side, it is called left coset. Small a is right side, that is the right coset. These both cosets are called simply cosets. Now cosets of the subgroup 4Z of Z. Let G be the additive group of integers. Now G equal to -4, 3, -2, 1, 0, 1, 2, 3, so on 1 means integers means 0, plus or 1, plus or -2, plus or -3, so on like that. In that group 0 is the identity element, so it is the additive group means it is the abelian. So let H be the subset of G. Now H equal to 4Z means so and so -16 means you have to multiply 4 by G means -16, -12, -8, -4, 0, 4, 8, 12, 16, so on like that. Therefore H is a subset of subgroup of G. The left coset of H in G is always right coset of H in G. Now cosets of H in G are A plus H, where A belongs to G. 0 plus H means we have to add the 0 to the 4Z means so and so -16, -12, -8, -4, 0, 4, 8, 12, 16, so and so like that. Now 1 plus H, we have to add 1 to H means 1 minus 16, that is the -15, -11, -7, -3, 1, 5, 9, 13, 17 like that. Now 2 plus H means we have to add 2 to the H means 2 minus 16 means -14, -10, -6, -2, 2, 6, 10, 14, 18, so on like that. Now 3 plus H, similarly you have to add the 3 and 4 and 5 plus, so similarly up to 6, so on like that. Next it can be observed that 4 plus H equal to is equal to 8 plus H equal to so and so 0 plus H means wherever A4 is there, that is the 0 plus H. 5 plus H equal to 9 plus H means equal to 13 plus H equal to 1 plus H. Why? Suppose 5 plus H equal to means in that 4 is subtracted by 5, that means 1 is the answer, so that 1 plus H like that. 6 plus H means 2 plus H. 7 plus H means 3 plus H. 8 plus H means that is the 0 plus H. 9 plus H means that is the 1 plus H. So therefore 0 plus H, 1 plus H, 2 plus H, 3 plus H are the disjoint sets. That is, there is no common element between them, and 0 plus H union, 1 plus H union, 2 plus H union, 3 plus H union equal to G. Therefore the cosets are 0 plus H, 1 plus H, 2 plus H, 3 plus H like that. Now properties of the cosets. These are the very important. So properties of coset is that 8 properties are there. 8 properties are there. So first one, if H is any subgroup of a group G and A, B belongs to G, then first one, A belongs to AH means A అనేది A belongs to H అంటే లెఫ్ట్ కోసెట్లో కోసెట్లో ఒక ఎలిమెంట్ అని చూపమంటుంది. నెక్స్ట్ let E be the identity in G, that is E belongs to G, that implies E also belongs to H because identity element G is as well as H in same. హెచ్లో జీలో ఏదైతే ఎలిమెంటో సేమ్ ఉంటుంది. జీలో ఏదైతే ఐడెంటిటీ ఎలిమెంట్ ఉంటుందో హెచ్లో కూడా సబ్ గ్రూప్లో కూడా అదే ఎలిమెంట్ ఉంటుంది కాబట్టి దేర్ ఫోర్ ఈ బిలాంగ్స్ టు జీ అయితే దట్ ఇంప్లైస్ ఈ బిలాంగ్స్ టు హెచ్. దేర్ ఫోర్ ఏ ఈక్వల్ టు ఏ ఇంటూ ఈ, ఇట్ ఈస్ ఎ ఫార్మ్ ఆఫ్ ఏహెచ్ దట్ ఇంప్లైస్ that belongs to AH, therefore A belongs to AH. Now second property, AH equal to H if and only if A belongs to H. ఎప్పుడు కండిషన్ సాటిస్ఫై అవుతుంది? AH equal to H అయితే if and only if A belongs to H. Let AH equal to H, that implies from the first condition, first property, A belongs to AH అయితే ఏమవుతుంది? A belongs to H. H equal to AH means therefore AH equal to H, that implies A belongs to H. Now vice versa, suppose let A belongs to H, that implies AH belongs to AH for H belongs to H, where that implies A belongs to H comma H belongs to H, that implies AH belongs to H, that implies AH subset are equal to capital H. Since A belongs to H, that implies A belongs to AH from the first condition, that implies H subset are equal to AH from the both H equal to AH or AH equal to H for A belongs to H. Now third condition is the very important from the exam point of view. AH equal to BH means left cosets are equal if and only if A belongs to BH. Very simple. First let's take AH equal to BH. Since from the first condition A belongs to AH, since AH equal to BH కాబట్టి మనకి ఏమొస్తుంది? A belongs to BH. Simple, very simple. Now therefore AH equal to BH implies A belongs to BH. Now we take, let A belongs to BH, we have to prove that AH equal to BH. So for that we have to multiply B inverse on both sides. That means B inverse A belongs to B inverse B into H. B inverse A belongs to EH means B inverse into B always identity element, so that implies B inverse A belongs to EH. EH equal to always H, that implies B inverse A belongs to H. That implies suppose A belongs to H means AH belongs to H, that means B inverse AH equal to H. Now we have to multiply B on both sides, so we get B inverse AH equal to BH. B into B inverse always E, that implies EAH equal to BH, that implies E into A equal to A, AH equal to BH, therefore AH equal to BH for A belongs to BH. Now fourth property is the very easy and important. AH equal to BH or AH intersection BH equal to 5 means two left cosets are equal or intersection is the empty set, implies any two left or right cosets of any subgroup are either identical or disjoint. Means any two left cosets or right cosets are equal లేకపోతే disjoint. So for that the two left cosets of a subgroup H are AH and BH అనుకుంటే, if they are disjoint means వేరు అనుకుంటే, then means వేరు means in that there is no common element, so that AH intersection BH equal to 5. మనం వేరు అనుకుంటున్నాం కాబట్టి మనకేమొస్తుంది? ఇంటర్సెక్షన్ ఎలాగో మన ఎంటీ సెట్ వస్తుంది, దేర్ ఈజ్ నో కామన్ ఎలిమెంట్ బిట్వీన్ దెమ్. నెక్స్ట్ let AH intersection BH does not equal to 5 means at least one element common ఉందనుకుంటే, then there exists at least one element C such that C belongs to AH intersection BH. That implies C belongs to AH and as well as C belongs to BH. Now C can be written as C equal to A small h1 and c equal to small a into small h2, where h1 comma h2 belongs to capital H. Left side c is the equal to means a h1 equal to b h2. Next you have to multiply h inverse on both sides. A h1 into h1 inverse equal to b h2 h1 inverse. Now left side a equal to b h2 h inverse. That means h2 h inverse means that is we take that h3, a equal to b h3. So b h3 means h2 into h2 h1 inverse. Now that implies a belongs to bh, also a belongs to ah. That means ah subset are equal to bh. Similarly we have to prove that bh subset are equal to ah. From the both conditions we say that ah equal to bh. Therefore the two left cosets are either identical or disjoint. This is a very very important property. Now fifth property ah equal to bh if and only if a inverse b belongs to h. Now this is a very very important. This is also exam point of view or entrance purpose also very important point. What is that? Ah equal to bh if and only if a inverse b belongs to h అవుతుంది. This is a very very important condition. Now see, let first condition is the let ah equal to bh అనుకొని we have to prove that a inverse b belongs to h. Now let ah equal to bh. Now I am taking b equal to b into e belongs to bh, because a equal to ae belongs to ah. Similarly we can write that we have to write here b equal to be, that belongs to bh. That implies b belongs to bh. That implies b belongs to ah, because ah equal to bh kabatti bh బదులు I kept here ah, so that b belongs to ah. Now I am multiplying a inverse on both sides. So a inverse into b belongs to a inverse into ah. Now a inverse b belongs to a inverse into a means e into h. That implies a inverse b belongs to h. That implies therefore ah equal to bh అయితే that means we will get a inverse b belongs to h. Now we take the a inverse b belongs to h. We have to prove that ah equal to bh. This is a very very important condition. So that now I am taking a inverse b belongs to h. That implies a inverse b h equal to h. Now a into a inverse b into h equal to ah. That means e into b into h equal to ah. That is equal to bh equal to ah. That implies ah equal to bh for a inverse b belongs to h. This is the very very important condition. Next, order of ah equal to order of bh means left coset lo any two left coset number of elements in left or right cosets are equal. లెఫ్ట్ కోసెట్ డిఫరెంట్ లెఫ్ట్ కోసెట్ తీసుకుంటాం కదా. ఏదైతే ఏహెచ్ అనేది ఒక లెఫ్ట్ కోసెట్ అనుకుంటే, బీహెచ్ అనేది ఒక లెఫ్ట్ కోసెట్ అనుకుంటే, ఏహెచ్లో ఎన్నైతే ఎలిమెంట్స్ ఉన్నాయో బీహెచ్లో కూడా అన్ని ఎలిమెంట్స్ ఉంటాయి. దట్ ఈస్ ద కండిషన్ మీన్స్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఇన్ లెఫ్ట్ కోసెట్స్ ఆర్ రైట్ కోసెట్స్ ఆర్ ఈక్వల్. దట్ మీన్స్ if ah function ah to bh where f of ah equal to bh for a comma b belongs to g where h belongs to capital H. Let ah1 equal to ah2 for all h1 comma h2 belongs to h. That is the aa cancel anukunte h1 equal to h2. Now multiplying bh1 equal to bh2, that means f of ah1 equal to f of ah2. That means function is well defined. Next, f of ah1 equal to f of ah2 where h1 comma h2 belongs to h. That implies by the function bh1 equal to bh2. Now left side the B get cancel, h1 equal to h2, that can be written as h1 equal to h2, that means f is 1 1. Now also bh1 bh dash belongs to bh అనుకుంటే h dash belongs to h, that implies ah dash belongs to ah, that implies a bh dash equal to f of ah dash, that means f is onto. Therefore f అనే ఫంక్షన్ ఇక్కడ నుంచి ah to bh is the 1 1 and onto. Therefore number of elements are equal. Right, next seventh property. Let ah is the subgroup of G if and only if A belongs to H. Simple. Ah is a subgroup of G if and only if A belongs to H. That implies let ah be the subgroup of G. That implies E belongs to ah, also E belongs to EH. That implies ah intersection EH does not equal to 0. That implies ah equal to EH equal to H. That implies ah equal to H. That implies A belongs to H. Let A belongs to AH implies AH equal to AH. Next, eighth property is the A1H comma A2H so on AKH be the different left cosets of H in G. That implies A belongs to G. That implies AH equal to AIH, where 1 less than or equal to I less than or equal to K, means I is the between 1 and K. That implies A belongs to AH. Each A belongs to G must belong to the AI. HI belongs to AI HI for I equal to 1 to so on K. Therefore A1H union A2H union so on AKH equal to G, means all left cosets are equal to G. That is the these 8 properties are important for exam point of view. These are the properties of the coset. Now once again, what is the coset means? If H is a subgroup of G, then the set AH equal to A into small h, where small h belongs to capital H, is called the left coset of H in G generated by A, and the set HA equal to small h into A, where small h belongs to capital H, is called the right coset of H in G generated by A. These two left coset and right cosets are simply called cosets of H in a group G. Now if H equal to 0 comma plus or minus 3 comma plus or minus 6 comma plus or minus 9, and find the all the left cosets of H in G. Now given that H equal to 0 comma plus or minus 3 comma plus or minus 6 comma plus or minus 9 so on. Now Z equal to 0 comma plus or 1 plus or minus 1 comma plus or minus 2 comma plus or so on, like that. The left cosets of H in G is given by A plus H form. So 0 plus H equal to same. What is the H means? You have to add 0 to the H, means same. 0 comma plus or minus 3 comma plus or minus 6 comma plus or minus 9 so on. That is the H. 1 plus H equal to 0 plus 1 comma 1 plus or minus 3 comma 1 plus or minus 6 comma 1 plus or minus so on, like that. That is the answer is the 1 comma 4 comma minus 2 comma 7 comma minus 5 comma 10 comma minus 8 so on, like that. 1 plus H, you will get the answer so on, minus 8 minus 5 minus 2 1 comma 4 comma 7 so on, like that. Now 2 plus H means 2 plus 0 2 plus or minus 1 comma plus or minus 3 comma plus 2 plus or minus 6 comma 2 plus or minus 9. We will get the so and so minus 7 minus 4 minus 1 2 5 8 11, so that means minus 1 plus H. Simply minus 1 H plus equal to minus 1 comma 2 comma minus 4 comma 5 comma, like that. Now minus 2 plus 0 so on, like that. We will get minus 2 plus h equal to so and so minus 11 minus 8 minus 5 minus 2 1 4 7 that is equal to 1 plus h. Now similarly 3 plus h equal to 3 plus 0 comma 3 plus or minus 3 comma 3 plus or minus 6 comma 3 plus or minus 9 so on like that. Now we add this one 3 comma 6 comma 0 comma 9 comma minus 3 comma 12 comma minus 6 so on like that. That is simply we have to write minus 6 comma minus 3 comma 0 comma 6 comma 9 comma 12 so on like that. That implies 0 comma plus or minus 3 plus or minus 6 comma plus or minus 9, that implies that is the h. 3 plus h equal to h. Similarly minus 3 plus h equal to h, 4 plus h equal to 1 plus h, and minus 4 plus h equal to minus 1 plus h, and so on. Therefore all the left cosets of h in G are h comma 1 plus h comma minus 1 plus h.